Hello guys, welcome back to my channel, and today let's learn about how to identify any type of fault you saw in the field. So let's begin quickly. So Ramsay is giving some classification of how to classify the fault based on the shape and the thickness of the thickness of the limbs of the fall. So let's draw a simple fault first, so it will help you to understand easily. And let's draw a thickness of the fold layer. So this is a fold, and here I'm showing the face part of a fold, any type of fold. Okay, so when we draw a plane here, this is called an axial plane of a fold. So from front we saw as a line, so this line is called a so here this line is called a orthogonal axis. So actually it's a plane, it's an axial plane. So first let's learn about what is div isogon. What is div isogon? Div isogon is a line that connects points of equal div or equal inclination on the inner and outer boundary surfaces of a folded layer. So simply let's see, we got a fold layer here, outermost layer and innermost layer. So when we draw a two line that cuts the two outer and inner layer of the fold and having a same amount of inclination, that two line should have a same amount of inclination alpha or any theta, and should cut a point, a point, only one point from outer part of the fold layer and inner part of the fold layer. At one point the two lines should cut, and after that, after cutting, they should make a equal angle with respect to this line drawing on the uh, touching the hinge of the fold. So the line that connects the 2 point is called the dip isogon. This PQ is called the dip isogon. And here when we extend those two lines, and when we draw a perpendicular line connecting these two parallel line, then there is called the orthogonal thickness of the point. These two you have to know, orthogonal thickness and dip isogon. Okay, so let's begin. So he is giving a three type of classification: class 1, 2 and 3. So the most easy way to learn is how the dip isogon is uh, oriented in a different three types of fold. So it's like a conversion, parallel and divergent. This for class 1, 2 and 3 fold. The class 1 fold, the dip isogon will be converging towards the core area. This area is called the core of the fold. It will converge, and in class 2 fold it will be equal and diverge in the class 3 fold. So this is the primary characteristic we have to look in the fold, whether it's a class 1, 2 or 3. So further in detail, in class 1 we have got a 3: class 1A, class 1B, class 1C. So the thing is that they are convergent isogons. The dip isogons are converged towards the core area, and the outer arc is greater than the inner arc. The outer arc, here we see the outer arc is greater than the inner arc. ठीक है. So it means the wideness of this curve. It means the wideness of the curve. All right. So when we see the class 1a, we have got one main point to remember here. That is the thickness of the orthogonal thickness. The orthogonal thickness is minimum at the hinge. We have known the orthogonal thickness, and it is minimum at the hinge, right? So the thickness are increasing while moving outside. Orthogonal thickness means uh, perpendicular line which uh, uh, which connect the two that uh, line, the thickness of this perpendicular line. Okay, so they are uh, the orthogonal thickness is smallest at the hinge area, and when we go to class 1b, it is called a parallel fold, while the orthogonal thickness are uh, the orthogonal thickness is almost equal throughout the fold layer. That's why this is called a parallel fold, and the isogons are converging. And class 1c, we have got orthogonal thickness is widest in the hinge area of the fold. As we know that hinge of the fold we already learned, so it is thickest in the hinge area, and it will keep on decreasing away from this hinge area. And when we go to class 2 fold and class 3 fold, the main thing we have to know in this class 2 fold is called a similar fold. In exam, in even jam, IT jam exam, they will give some option, and they will give class 1 2 3 fold, and they will ask you to find which one is the similar fold. So here we have to know a few points. Here the div isogons are parallel. All the div isogons here, they are marking div isogon here. It is a parallel. Div isogons are parallel, neither converging or diverging. And the outer arc and inner arc are similar. The wideness and the curving, how they are curving, they are almost, they are same. The outer arc and inner arc. And moving towards class 3 fold, it says that the div isogon is diverging from the core. It's diverging like this. It's diverging from the core. So these are the basic characteristic of different types of classification based on Ramsay's for classification. Okay, thank you, bye.